Okay, let's see. First question. What type of pure substance can be decomposed chemically into other pure substance? A compound, B, a mixture, C, I'm sorry, a compound, B, an element, C, a mixture, D, a solution, E, a heterogeneous matter. Okay, put your answer in the chat box. Can you guys hear me?
Yeah,
What do you guys think? You got five possibilities. So one of five is going to be right. So what do you guys think? Are you guys having trouble staying in, or is it my computer being wonky?
I
Because you
think
guys keep coming in and out. Are you guys having issues with stability?
yeah.
Yeah. Okay. So Israel says A. Do you guys agree with Israel?
Yeah.
Okay. So the correct answer is A. So the definition of a compound is two or more atoms bonded together. So if the compound is a pure substance and we break it down, we can break those down into other pure substances, either pure elements or another pure compound. So that is correct. A book is pushed off the table. It falls to the floor. Which of the following statement is true about which of the following statements about the book is false? A, its potential energy is at the maximum just as it leaves the table. B, its kinetic energy is at its maximum just before it hits the floor. C, its kinetic energy is equal to its potential energy at the halfway point between the table and the floor. Uh, D, the potential energy is reduced. E, all of the above are true. Hey, what do you guys think? A, B, C, D, or E? Okay, which ones can we eliminate? Which one of these are true? Okay, you got one of five possibilities. If you guys can put your answers in the chat window, that'd be perfect. Okay, so someone says that B is true. That's true. So I'm going to put a T over here by it. Someone says A is true. So its potential energy is going to be maximum just as it leaves the table, right? So that's going to be the highest height it's going to be. So that's actually true. And it says, what about C? Somebody said C is true, which it's going to be half kinetic and half in between. So then we have two possibilities of being false. So its potential energy is reduced. Is that true? So think about the consequences. What happens when we push it off the table and it falls to the floor? Isn't it consistently reducing its potential energy? So that is actually going to be true. So the correct answer is actually E. All of the above are true. Okay. So it was a kind of a trick question in a sense, because you have to read the what the question was asking us and what's happening in the question. So the book is falling off the table, right? And so as it falls off the table, the lower it gets, it's going to be reducing its potential energy, and its kinetic energy is going to increase. Does that make sense? So the the big component here is that energy is always going to be conserved. And so if you're changing from potential energy, then you're going to be converting that to kinetic energy. Okay. And those energies at the end are going to be equal to the value. What you're starting out should equal what you end up with. So what law is that? Anyone? The law of what? That's right. Law of conservation. That is correct. Okay. Question number 3. The form of most elements is the same as the symbol of the element. This indicates that the element is stable as a single, the smallest unit particle of the element. The other elements exist as stable, distinct, and independent, so which are made up of two or more atoms. Okay, so we have to fill in the blank. So the first one is I, the second one is II. So which says this indicates that the element is stable as a single blank, the smallest unit particle of the element. So is that first blank, is it going to be molecule? And then the second blank would be particles? Or is the first blank a molecule? The second one is a crystalline solid. The third one is crystalline solid, possibility, and molecule. The fourth one is atom. The second one is an independent mixture. The fifth one is an atom and a molecule. So is it A, B, C, D, or E? Okay, so the set says it is E. Do everybody agree with Lisette? Well, yes, it is E. Good job, Lisette. So when they talk about the smallest unit particle of an atom, so that's typically the atom. I mean, we're talking about an atom. And then the second part is a molecule because it's made up of two or more atoms that are bonded together. Okay, next question. Okay, so these are models for potential models for silver. So it says, which of the following particulate level picture might be associated with the name silver? Okay, so when we talk about models, a lot of times we use models to sit there and depict atoms. It can be used to depict mixtures. It can be used to depict compounds, or it can be used to depict all. So if we take a look at the very first one, what does that look like? So we have a little black ball attached to a white ball, a little black ball attached to a white ball, and then we have this bigger, we'll say grayish ball attached to a darker grayish ball. So what would you guys think this would represent? Would that be a mixture? Would that be an atom or a single atom? Would that be a compound? Would it be a molecule? Now, if you guys are shy and you don't want everybody else to know your answer, you can message me your answer. Okay. So in a sense, this basically would be an example of two molecules, right? So these two are the same, and these two are the same. So then if you have two different molecules in one container, so what would we call that? So if I have salt and sugar in a container, what would I call that? Would that be a pure substance? Would it be a compound? Would it be a mixture? Would it be a homogeneous mixture? Would it be a heterogeneous mixture? So let's talk about the definition of a compound. A compound is two or more atoms bonded together. So this here would represent two compounds that are in the same thing. So if I have two independent compounds that are mixed together, like sugar and salt, would that be a compound, one compound, or is that two compounds? That's right, it's two compounds. So if I have two compounds mixed together, that's called a, isn't that called a mixture? That's right, a mixture. Okay. So we know that this very first one is a mixture. So I'm going to type that up there. Okay. What about this guy? We have balls that are all exactly the same. So and they're forming a solid. So you gave me two things, right? So if we think it's silver, is silver a solid? Or is it a gas, or is it a liquid at its natural state? Yeah. So we know it's a solid at, so we would assume that this would be for silver because it's exactly one type of atom, right? So this here would be just atoms. This would be a pure substance. It's pure. And so we would assume that this would be silver because silver is only a single type of atom. Okay, these are all exactly the same, so that would represent silver. So the correct answer would be B. Okay, so why wouldn't this be silver? It would be a solid. This one up here is probably a gaseous mixture. But C, why would it be? Are all of the balls exactly the same here? No. So because they're not exactly the same, that wouldn't be a pure, it would be a compound, but it wouldn't be, and it would be pure, but it wouldn't be just a single compound or a single element like silver because you have two different balls rather than them being both the same. So we would have a pure compound and it would be a solid. What about this one here? What's wrong with it? Why isn't it? Why can't it be silver? It's not a solid. That's true because they're separated. So that would be one reason. The other reason would be they're different shapes or different sizes. That's right. And what about the last one? Why wouldn't that be silver?
Mm.
You're gonna say just something, Julian?
Yeah, but I was gonna say it's because it's not a solid, but they already
That's
talked
true.
about.
It's not a solid. That's true. And then anything else? What do we notice about, are
It's,
these the
it's,
same?
no, they're not the same as the other one.
Yeah. So they're not two of the same atoms. They're two different
Hmm.
atoms that are bonded together.
Yeah.
Yep. Good job. So we know that again, it's B. The correct answer is B in this case. Number 5. Get my glasses on. Which of the following statements is false? Both elements and compounds Both elements and compounds are pure substances. The properties of a compound vary. An element cannot be decomposed chemically into other pure substances. A compound can be separated into other substances by chemical means. Or all the above are true, none is false. Okay, so Lisette says she wants to say the last one, but she's not too sure. Well, the correct answer is the last one. All of the answers above are actually true. So we know that both elements, if you have pure gold, just element by itself, it's pure, right? If we have pure uh, sugar, then we know that's pure as well. So they both can be pure substances. So the definition of pure can pertain to both an element, it can pertain to a molecule, or it can pertain to a compound. And then the properties of a compound, we know that they're going to vary, right? So for instance, we know that water boils at 100 degrees Celsius, and alcohol boils at 86.3 degrees Celsius. So they have different properties. Not all compounds are created equally. And then the third one says an element can't be decomposed. Well, if it's an element, let's say it's gold, you can't break it down to anything smaller. You can only break it down to gold. That's it. And then it says a compound can be separated into other substances by chemical means. So if I break down water, I can break that down to oxygen gas and hydrogen gas. So yes, so I can break down compounds into smaller parts. So they're all true. So it would be E. Any questions? Okay. Number 6, examine the apparatus shown in the following image. This apparatus would be useful in which of the following separations? A, oxygen from nitrogen dioxide. B, sand from a mixture of sand and water. E, rubbing alcohol from a mixture of rubbing alcohol and water. F, iron fillings from cereal. D, iron fillings from cereal. And E, hydrogen and oxygen from water. The correct answer is C. Yeah. So this is called a distillation column. It basically allows two liquids to be separated from each other by a change in boiling temperature. And so we're able to sit there and put one in the gaseous phase and then collect it in this tube over here, and then keep the other liquid here by changing the temperature to a certain point that allows the two to separate. So good job, Julian. You guys are doing good. Under what condition is the law of conservation not obeyed? A, digestion of food. B, human and some animals metabolizing of sports drinks. C, high-speed travel, such as a jet, a military jet, and a space shuttle. E, nuclear changes. F, the law of conservation of energy is always obeyed. That is correct, Israel. Nuclear changes. Oh, sorry. What is nuclear changes? Nuclear changes is if you split an atom and then you use that splitting of the atom to actually make another atom and left over from that splitting of the atom, you generate a whole lot of energy. Okay. So for instance, or if you put two atoms together, you can also generate a lot of energy. So recently, they've been able to do fusion, which is basically bringing two atoms together and bonding them together to make energy. It actually makes a whole lot of energy as well. So that's called nuclear fusion, when you bring two atoms together to make a new atom. And then fission is when you split atoms to make energy. And so we're capable of doing both. They make a lot of energy. And so the law of conservation isn't conserved, or at least the way that we've looked at it, it isn't conserved because we're able to generate a whole bunch of energy from a little bit of energy. That's right. So the correct answer is D as in donkey. Okay, number 8. Considering the following measurements. Considering the following measured number. 640,000 meters. If this measurement were to the nearest kilometers, what should be the answer? What should the answer be expressed in exponential notation or scientific notation? Okay, so we got a couple of answers. So let's go ahead and take a look. Okay, so we want to put in scientific notation. So the decimal would normally start here. So we're going to move it back. 1, 2, 3, 4, 5. So the correct answer should be but we also says it also says um, if we make, this is a good question. If the measurements were made to the nearest kilometer. So the nearest kilometer, so that would be 6.4, and then that's 0, because a kilometer is 1,000 times less than a meter. I mean, 1,000 times, yeah, 1,000 times less. Kilometer is 1,000 times greater than a meter. Sorry. Um, so then that'll be 1, 2, 3. That will be 1,000. So then we want to keep this number so that we can have that as our sig figs. So it should be B. Correct answer should be B, not A. My bad. By my eraser. So correct answer is B as in boy, because that part right there. Otherwise, they technically would all be correct. Okay. So Israel, good job. Don't second guess yourself. Okay. Okay, so the next question, it says, the energy of a photon of light is directly proportional to the frequency of that photon. Calculate the value of the proportionality constant given that a photon of given that a photon of energy 4.4 times 10 to the negative 19 joules has a frequency of 6.7 times 10 to the 14th seconds. Okay, so the idea is that we're going to calculate the constant. Now read what it tells us, this first part here. Okay, it says a photon of energy of light is directly proportional to the frequency of light. So what does that mean? What does directly proportional mean? So as one of them go up, what is the other one going to do? If it's directly proportional. Okay, let me ask you this. So let's say for a whole month, you eat as much as you could possibly eat until you get sick to your stomach. Okay. So, in other words, you're eating a lot more food than you normally eat. Are you going to get bigger? Yes. Okay. So, that would be an example of being directly proportional. So, the amount of food that you eat to you getting bigger are going to be directly proportional to each other. The more food you eat, the bigger you're going to get, right? So, that would be directly proportional. Inversely proportional would be the more food you eat, the smaller you get, which we don't happen to us, right? So if it's directly proportional to each other, that means that they're going to be going up together, right? So what we're saying is that we're going to say a photon energy. So we're going to use the symbol E for energy. It's not going to be equal. It's going to be proportional to frequency. And so for this, we're going to put We're just going to use freak. Later on, I'll show you what the symbol for frequency is, but. Okay, so since these guys are directly proportional to each other, we can make them equal to each other by putting a constant. So we're going to use a constant, and we're going to use that constant K. So K times freak will equal energy. Okay, so now we need to solve for K. Okay, so we say that energy divided by freak will equal K. And so then you just put the energy in, and then you put the frequency in, and then you should get what K is. So we have oops. Times 10 to the minus 19. Let me fix that. And that's joules over 6.7 times 10 to the 14th. And that's 1 over seconds. Okay, so since this is already 1 over seconds, when we divide it by something above it, that's just going to give us a number in, it'll be seconds, and then it'll be joules seconds. So if we do this number here, what do you guys end up with? Okay, so if you guys are plugging this into your calculator, you're going to plug it in as 4.4 EE that EE is a button. And then there'll be either plus or minus or a minus button like this. It'll be plus or minus. That'll be a button too. In parentheses, and then 19. And then you're going to divide it by, so then you're going to use your division sign. Oops. 6.7. And then again, you're going to use your EE button. And then in this case, it'll be 14. So if you've done this, you should end up with the answer 6.6 times 10 to the minus 34, which just happens to be Planck's law. Okay, questions? So yes, you're correct. You would have to divide in this case. Okay, you guys ready for the next one? So the question was, why is it joules seconds instead of joules divided by seconds, because the unit here is technically 1/seconds is what we have under here. So it's, even though it doesn't have that one, it's technically 1/seconds, which is considered a hertz. Okay, now since we have that division, right? So if you have another division on over here, it flips this. So if you had 1/seconds, that would just flip this so that you would end up with seconds. Okay. So anytime that you have a fraction or something divided by something, by you dividing that by something divided by something, it just gives you whatever that number is on the bottom. That'll just be on top. Okay. Good question, though. A lot of students actually make mistakes on that. So, okay. The Willis Tower in Chicago is 1,451 feet tall. How high is this in meters? 1 inch equals 2.54 centimeters. Okay. So what's my given? Okay. So we have 1,451 feet. So that is going to be my given. So I always want to start off with my given. Now, this here is a conversion. So that's not really our given. It's just a conversion to let us know what the conversion is. So how many inches are in 1 foot? So we know that 12 inches equals 1 foot. Okay. So if I want to get rid of feet, am I going to have feet on the bottom or on the top? So we're going to start with our given. And so typically how I always determine my given, for the most part, there will be an exception every once in a while. They're the one that only has a single unit, like they'll have feet or they'll have inches or they have miles or something like that. But it's only that unit. Typically, when you have something over something, that's going to be used as a conversion. So do we want feet on the top or on the bottom if we want to get rid of it? So if I have X, if I want to get rid of X, am I going to multiply it by X or am I going to divide it by X? That's right. We're going to put it on the bottom. So we want to have feet on the bottom. Okay. So we have 1 foot on the bottom, and that means that we're going to have 12 inches on top. Okay. Then how many inches are in a centimeter? Or how many centimeters are in an inch? Aren't we given that? Okay. So do I want inches on the bottom or do I want inches on top? Okay, so we've gotten rid of feet. They cancel each other out. So now we have inches on top. So if I want to get rid of inches, that's right. I'm going to put inches on the bottom. And then we're going to put our 2.54 on top, and that's centimeters. Okay, how many centimeters will equal 1 meter? That's right, 100 centimeters equals 1 meter. Okay, so do we want to put centimeters on the bottom or do we want to put centimeters on top? Since I want to get to meters, that's my goal. That's right, we're going to put it on the bottom. So I'm going to put our 100 centimeters on the bottom and then our 1 meter on top. Okay, centimeters cancel out. So since we have one, one, and 100. So then basically we're just going to go 1,451 times 12 times 2.54 divided by 100. And what do you guys end up with? Okay, so you guys said E as in Edward. That would be correct. And you notice that we have 4 significant figures because what we're starting off with had 4 significant figures. So our answer should end up with what we started off with in this case. Okay. How's it going? How you feeling so far? So how would you rate the test so far? Easy, hard, intermediate? Okay. Okay. So let's see. Complete the following operation. So we have 9.370 times 10 to the minus 5 minus 2.25 times 10 to the minus 6. Okay, so you guys ended up with D as in donkey. Good job, Israel. Okay, number 12. Okay, number 12. It says, how many significant figures are in each of the following quantities? So, the very first one, I. How many sig figs do we have? Okay, so let's talk about sig figs real quick. So if it's a non-zero number, that's always going to be considered significant. So any number except 0 is always going to be considered significant. Now, zeros are significant when they're in between two non-zero numbers. So they're called captive zeros. So let me give you an example. If I have 202, so that would give me 3 significant figures. Okay. They're also considered significant if we decide to put a decimal where we don't need it. So like here, we don't have to put a decimal there. That's just extra work. The fact that we did extra work, that tells us that these zeros are significant. So if I decide to do this, 2, 0, 0, 0.00, now I could have just said 200 and called it a day. But the fact that I put 0.00, that means that these guys become significant. Okay. So in this case, this guy would have 5 significant figures, 5 sig figs. This guy would have 2 sig figs. Okay. So for the very first one, I has how many significant figures? Oh, and I should tell you this one. So these zeros here are called placeholders. They just let us know that the number is going to be really small. So then you would only count the non-zero numbers unless it follows the non-zero numbers in the case of having a decimal in front. Okay. So in this case, this is only 2 sig figs. So I has how many sig figs? 2. That's right. So we know it has 2. Okay. So those are your 2 significant figures. So we can get rid of this one and this one. So we know that those are wrong. Okay. Now what about I? How many sig figs does that have? It has 3. That is correct. Because again, we took the extra time to put that 0 there after that decimal. So then we know that that's going to be significant. So we should have 3 significant figures. So we know that that one's incorrect and that one's incorrect. So we don't even have to finish doing the rest, but we will just for kicks and giggles. So how many sig figs do we have here? Now everybody should be able to answer this because we have the answer circled.
4.
4. Okay. So we have 4 sig figs. The exponent doesn't count towards our sig figs. So just that first number does. Okay. And then the fourth one, it has 3. That's right. Okay. Questions? Okay. We'll keep moving forward. And if you don't ask questions, I expect you guys to get 100% on the exam. No pressure or anything. So you had a question on question 11? Is that, oh, what was the answer to question 11? So the answer to question 11 was D. So you are correct. Number 13. Which of the following numbers are correctly expressed in ordinary decimal form? Okay, this is first one. So 1, 2, 2, 3, 4, 5. So is I correct? So I isn't correct. So let's do that counting here. Okay, so That's 1, 2, 3, 4, 5. So that would be 10 to the 5. So then that is the same. They equal the same number. What about, so I is correct. What about I? Is that correct? No, that's right. So I isn't correct because this guy gets smaller. So then it should have a negative value. So then that will be 1, 2, 3, 4, 5, 6. So it should be a negative in front of it. So we know that that one's wrong. Okay. This one is -4. So then that's 1, 2, 3, 4. So then that one is right. And then this one it says a -3 and it's going the wrong direction. So it should have been a +3. So that one's also wrong. So, okay, so the correct answer is B as in boy. Okay. Do you guys see that? Yes, no, maybe? Any questions on it? Anybody want to give me $1 million? 3 million? Okay. Okay, so we'll go ahead, keep going. Okay, it says, which of the following quantities is/are incorrectly rounded to 3 significant figures? Okay, so the goal is to get to 3 significant figures. So are there any ones that we can get rid of that are not successfully rounded to 3 significant figures? Okay, so let's see. So that very first one, is it 3 sig figs? Oh, so you're saying the one that is correctly rounded to 3 sig figs is the second one. It's I. Do you guys agree? Okay, so the second one is definitely 3 sig figs. Oh, is it wait. Let me take a step back. Is it successfully rounded to 3 sig figs? It is 3 sig figs, but is it successfully rounded? So what is the rule on rounding? If it's greater than 5, do we round up? If the number following that third significant figure is greater than 5, we round it up. Okay. So in this case, this guy should be rounded up. Okay. What about the third one? Is that successfully rounded to 3 significant figures? So that's 1, 2, 3. Yep. So the third one is correct. What about the fourth one? How many sig figs is that? Okay. So if we were going to look at 3 sig figs, then this is our third significant figure. So we'd use this 8 to determine whether we're going to round up. And in this case, since it's greater than 5, we'd round this number up. And so our answer would be, it would have been, if it was successful, it would have been 0.00340. Okay, we know that this one was correct. So the correct answer is C. Okay. Questions? Okay. Well, let's keep going then. You guys are so talkative. I can hardly get a word in edgewise. Okay. Question number 15. Determine if the following is a physical or a chemical reaction. slash property. A, cracking a glow stick. Is it chemical or physical? Are you sure? A glow stick. Well, I guess, the act of cracking would be physical aspect of it, but cracking the glow stick, we're talking about the chemicals on the inside. Is that going to be a chemical reaction that happens that causes it to glow? Okay. So it's going to be a chemical. What about boiling water? So water boiling, is that a chemical reaction or a physical reaction? Okay, physical. Adding Mentos in a soda. Chemical or physical? Physical. Gas burning in a fireplace. That's a chemical. That's right. A nail rusting. A nail rusting. So if we think about it, a good way of thinking about whether you can get if it's a physical reaction or if it's a chemical reaction is if you're able to get it back, right? Or if you're able to get the components back. Okay. So a rusty nail, can we make a rusty nail like a brand new nail without filing it off? We can't, right? So then that would make it would it be a chemical or physical reaction? Chemical. That's right. Okay. So determine the number of significant figures of the following. How many sig figs here?
3.
3. What about the second one?
Is it 3 as well?
You said it's also 3. That is correct. Okay, this one we have to add it up. Okay, so we have 21.00. We have 12.005. And we have 7.0000004. And then we have a huge number. 0, 0, and then a 0. And then we have 100. Okay, so the rule is that, and we're subtracting these. So we're adding all the ones up top. So we're adding these, and then we're subtracting that. Okay. So the way you would do it is you'd line up and significance here. And you're going to find the one that is the furthest to the left. So the second one technically is right here. And it's where significant ends. The third one is right here. The fourth one is right here. And the fifth one, let's see, is right here. Okay, so the one to the furthest to the left, so this would be the separation of the number that is significant from the numbers that aren't significant. So we just go ahead and do the addition. Go ahead and do that. That would be, what is that? So we end up with 12 point, 12, 0, 4, 0, point, 0, 0, 5, 0, 0, 4. Okay, so then we look at this number here to determine whether we're going to round it up or we're going to leave it alone. So in this case, we're going to leave it at 0. So then my answer should be 12, 0, 0, 0, because I need my placeholders. So how many sig figs would that be? That's right, it's 2. So we'd have 2 sig figs in this case. So our answer should be 2. Okay, so in the case of addition and subtraction, we have to do the lineup. In the case of multiplication and division, what is the rule? Okay, that's right. We go with the one that's the smallest. Okay, so the smallest number of sig figs. Okay, so which one would be the smallest number of significant figures? So this number here has how many sig figs? It has 4. That's right. What about the second number? That's right, it's 4. What about the third number? It's 3. Okay, and then the last number? No, it's not 1, because we took the time to put the decimals and the zeros after it. That always means that it's going to be significant. Because otherwise we could have just wrote 9, right? So then how many sig figs would this be? That's right, it's 6. Okay, so the smallest one is 3. So we're going to go ahead and do the math. And then we'll determine the number of sig figs. Okay, so we should have 3 significant figures. I guess we didn't have to do the math, but to figure it out. Okay, questions? Concerns? Cashola? No cash? Okay. Okay, clear. Can I go ahead and clear this? Are we good?
Yeah.
How are your brains? Are they doing okay? Okay, our next question. It says, your car is leaking gasoline at a rate of 0.025 gallons per minute. If that car has a 12-gallon tank and is full, how many hours will it take before your car is completely empty? And then the second part of the question says that if you are driving from Fireball to Salinas, 101 miles, to see your new boo or your new bay, you met in chemistry class at a speed of 75.0 miles per hour. Would you like let's say, would you make it before you run out of gas, assuming your car gets 32.0 miles per gallon? You start it with a full tank of gas. Your car is leaking gasoline at a rate of 0.025 gallons per minute. How many gallons of gas are left over or short? Or how many gallons of gas are left over or short? Please show your work. Please show work to support your answer for full credit. And then the third part, it says, your car overheats on the way there at a temperature of 325 degrees Fahrenheit. What would be the temperature in Celsius and Kelvin? Okay. So let's see. So let's start off with the very first one. Okay, so number 17. Okay, so we have the rate that our car is leaking, and we have 12 gallons tank, or 12-gallon tank. So then what is going to be my given in this case? Is it going to be that rate, or is it going to be my 12-gallon tank? That's right. It's going to be the 12-gallon tank. So we're going to have 12.00 gallons. Okay. And we want time, right? So how can I go from gallons to time, a unit of time? What am I going to use? So my rate, what are the units for my rate? It's minutes. It's gallons per minute. That's right. So I have gallons. So do I want to put gallons on the bottom to get rid of gallons? Or do I want to put gallons on top to get rid of gallons? On the bottom. So I'm going to put the 0.025 gallons on the bottom. And then I'm going to put, since it's per minute, that means per 1 minute, I'm going to put 1 minute on top. So, but I want hours. So how can I go from minutes to hours? So what is the conversion from minute to hours? How many minutes will equal an hour? Okay, so we know that 60 minutes. So am I going to put that on the bottom, or I'm going to put that on the top? Bottom, that's right. So I'm going to put my 60 minutes on the bottom since I want to cancel out the units. And then I'm going to put hours on top since that's what I want. Okay, so then gallons cancels out, minutes cancels out, and I'm left with just units of hours. So let's go ahead and do that math. Okay, so I'm going to end up with 8 point, with 4 significant figures. 8.00 hours. Okay. Part B. Okay, so this is a little confusing. Okay, so the second one, it says, so we're going to see our boo, right? And we're driving 75 miles per hour. So will we make it before we run out of gas? Okay. And then our car gets 32 miles per gallon. And we're starting off with the full tank. And my car is still leaking. Okay. How many gallons of gas are left over? Okay. So there are two questions that we need to ask. Whether or not we're going to make it without running out of gas. And then we want to know how much gas we have left over or that we're short. Okay, so those are the two things that we want to answer. So if we think about it, so I have my full tank down here. So B. So we have our full tank. Now, our full tank is losing gas as we drive. Is that right? Is there any other way that we're losing gas? No, just by driving, that's it. Okay, so we're going to subtract the amount by driving up. That's right. We have a leak as well. Okay, so we're going to subtract driving because we're losing gas as we drive. So we're just going to put drive. And then we're also going to subtract our leak. Okay, so how many gallons do we have if it's a full tank? What does it say? 12. Okay, so we have a 12-gallon tank. 0, 0. That's gallon. Okay, and then we're going to subtract the amount that we're going to have from driving. Okay, so hold on one second. Okay, so then we have about driving. So how far are we driving? We're driving to Salinas. And Salinas is 101 miles away from Fireball. So we're going to go ahead and start with that. So we're going to come down here and put drive. Okay, so that's going to be our given here is 101 miles. And we want gallons for that, okay? So if I have 101 miles, which one am I going to use to get to gallons? Am I going to use 75.0 miles per hour, or am I going to use 32.0 miles per gallon? Okay, so I'm going to use the 32, right? So am I going to put miles on the bottom since I have miles up top here, or on the top? On the bottom, that's right. So I'm going to put my 32 miles on the bottom. And we know that that's per gallon. So we're going to put our 1 gallon on top. Okay, so then miles are going to cancel out. And we're going to end up with so we had 3 sig figs here. So we're going to want to answer that's going to be 3 sig figs. So that's 1, 6. So 3.16 miles. Okay, now our leak. So we know our leak it's at a rate of 0.0250 gallons per minute. Okay, so we have our leak is going to be 0.025 gallons per minute. Okay, so if we want to determine how long our leak is going to happen or how much gallons are we going to lose, we're going to have to be able to sit there and figure that out. So how long does it take to get to Fireball? How would we figure that out? Or how long does it take to get from Fireball to Salinas? How would we go about figuring that out? What are we going to start off with? So I'm going to write my leak down here. Okay, so we have what are something that is just plain units? That's right. We're going to start off with the 101. That's right, the 101 miles. So we have 101 miles that we're going to be traveling. Okay. And do we know how long that's going to take us to travel? That's right. We're going to divide it by 75. That is correct. 75 miles per hour. Okay. So miles are going to cancel out. Now, our leak is in what unit? What unit is it in? What unit is this? So aren't these minutes here?
Yeah.
Okay. So we know that these are minutes, but we have hours. So how can I change minutes to hours or hours to minutes? How many minutes are in an hour?
60.
60. Okay. So for every 1 hour, we have 60 minutes. Okay. So then hours are going to cancel out. And we know we want to end up with gallons. So is there anything that has the unit of gallons and minutes? That's right, gallons per minute. That's correct. So we have our rate. So then we're going to put, since we want gallons, we're going to put our 0.025 on top. 250 gallons on top. And then we're going to put our minute on the bottom. Okay. So if we do that math, what do you guys end up with? So what value do you guys end up with? So just a reminder, you multiply everything that's on top by each other, and then you divide it by what's on the bottom. Okay. Anybody do the calculation? Anybody there? Okay. Well, you guys can figure out how to do the calculation. There we go. So then we're also going to subtract. So we end up with 2.0. And since we had 3 sig figs, 2.02. And that should be gallons. Sorry. This is 3.16 gallons, not miles. Okay. So the units all have to match up. They all have to be gallons. So you want to make sure that those units match up. Okay, so then we just do the math. Okay. So we end up with 6.82 gallons. So did we make it?
Yeah.
Yep. Okay. Yeah. If we didn't make it, we'd end up with less gallons, or 0. So then we'd be in trouble. Okay. Okay. So the third part is to convert from 325 degrees Fahrenheit to Celsius and Kelvin. So I'm going to put that down here. So that's part C. So how do I convert? What equation am I going to use? Okay, let's get Celsius first. Okay, so the equation to go to Celsius, so we're going to call it TC for Celsius. That's going to be equal to, you said, 9/5 Fahrenheit. Are you sure that's correct? 32. Isn't it the other way around? Isn't it? Yeah. Okay. So there's a couple of ways. So 9/5 is the same thing as 1.8. So we can divide this by 1.8. So let's correct that. Or we can just say 5/9. Okay. Okay. So now that we've got the right equation, we just plug in our degrees in Fahrenheit, TF. So then it's 325 minus 32. That's all going to be divided by 1.8. So I end up with 163 degrees Celsius. Okay, so now if I want to convert to Kelvin, that's right. So we'd go TC plus 273.15 is going to equal TK. Okay, so then we get 163 plus 273.15, and that's going to equal this. So they're not like right. Yeah. Okay. So what did you guys get? Okay. Questions? No questions? Okay, guys ready for the next part? Yeah, so you would upload the answer. So you have 30 minutes to upload all your written work. And so you with your written work, you'd upload that part.
So we wouldn't upload it right here where it says choose a file.
You can do it, but a lot of times what happens because
Mhm.
of Proctorial, it'll
Yeah.
block it, and so it won't let you do it.
Okay, so upload on the where it says on the
Yeah,
other
so
thing.
so there'll be an exam one upload. So then at the end of it, just upload all your scratch work and then also your answers, show your work so that I can actually give you full credit, you know?
Okay.
Okay. Did everybody get this down?
hmm
Okay. Let me clear. Okay. Number 18. Let's see, how many more do we got? Oh, we got a few more. Number 18. Okay. So we're balancing our chemical equation. Okay. So what would be the first step to balancing our chemical equation? What side is the product? What side is the reactants? Okay. So we're going to count, or we're going to break it down to our elements, and then we're going to count each of the elements. So I'm going to write this between the two reactions. So we know that this here is my reactant. And then this and this down here is my products. Okay. Okay, so how many carbons do we have in our reactant?
12.
How many uh hydrogens do we have in our reactant?
22.
Okay. How many oxygens do we have in our reactants?
13.
13. Okay. So you guys see the 11 here, and then you have two more over here. Okay. What about on our product side? How many carbons do we have on our product side?
Is it 1?
That's right. How many hydrogens do we have on our product side?
Is it 2? Or is it
No, that's right. It's two. Yeah. Okay. And then how many oxygens do we have on our product side?
3?
Okay. Okay. So is this balanced?
No.
No. Okay. So what do we need to do to balance it? Okay. So we're going to put, that's right. We're going to put 12 in front of the CO2 on our product side. So that's the coefficient. So it's 12 times 1, and that'll give me 12 carbons. So then how many oxygens do I have now? So I have 25. Okay. Because I have 12 times 2, which is 24, plus that additional 1, which brings me to 25. Okay. So then that takes care of the carbon. Now, what do I need to do to balance out my hydrogens? I have 22 on one side and I have 12 on the other. That's right. I'm going to multiply 11 times the waters. So we have 11 waters. So 11 times 2 is 20.
22.
Okay. And then how many oxygens do I have now? I have 12 times 2 here plus 11. 12 times 2 is 24 plus 11 is 35.
35.
Okay. Oops. So I have 35 oxygens. Okay. Now on the other side, this guy is set. The carbons are good, the hydrogen are good. So if I take that 35 and I subtract it by the 11 that I have here, what would I have left over? 35 minus 11. So then I don't have to worry about messing with the sugar or that first chemical. 24. Okay, 35 minus 11 is 24. So over here, I have 2 oxygens. So 2 times what will equal 24? 12. Okay, so we'll put a 12 here. So then that'll be 24 plus 11. So then that'll be a total of 35 oxygens that I have. And then it's understood to be a 1 here. So because the program itself, it doesn't understand that if there's nothing there, it'll mark it wrong automatically as if you didn't answer it. So you have to put a 1 there. So, okay. Questions? Okay. Okay, so I'm going to leave this one for you guys to work on yourselves. So write down the chemical equation. And then I'm going to go ahead and do one of the problems down below. Got to see if anybody's done the exam yet. I may change it a little bit because we have a lot of questions. And they take a little bit longer than I anticipated. Okay. Let's see. Which one of these are we going to do? Okay. Okay, so here, let's do number 20. It says the average temperature of a hot car engine is 200 degrees Fahrenheit. And your car heats up to 325 degrees Fahrenheit. If your car engine needs 6 quarts of oil with a specific heat capacity of 22.47345 joules per grams Kelvin and a density of 0.852 grams per milliliter, how much energy will need to bring it back to normal temperature? How much energy will you need to bring it back to normal temperature? I need to work on my grammar there. Okay, so let's go ahead and start working this problem out. So the equation that we're going to be using for this is going to be Q equals MCAT, M delta T. Okay. So we know that delta T represents that change in temperature. So we want that change in temperature to be, well, here's our temperature. But the units that we have are in Kelvin. So we need to change our temperature to Kelvin first. Okay. Okay. So we have it in Fahrenheit. We need to change it to Kelvin. Well, we know the degrees in Kelvin for the 325 because we did that earlier. So our T final, delta T is going to be equal to T final minus T initial. Okay, so in this case, we have our T initial is going to be the 325. We know that in Kelvin, that was what, 430, 436. Okay, so we need to change 200 degrees Fahrenheit to Kelvin. Okay, and we know that we can do that by subtracting the 32 and then dividing that by 108. I mean, 1.8. And this would change it to Celsius. And then if we go ahead and add the 273, 0.15, and that would change it to Kelvin. Okay. So I get 366 Kelvin. Okay, so sorry, 366. So I'm going to end up with negative 70 Kelvin. Okay. So now we just plug in our values. I guess we do need to figure out, we have quarts and we have gallons per grams per milliliter. So if I remember it correctly, 4 quarts equal a gallon. And 1 gallon equals 3 point, look that up. It's 3.7, I think it's 754. 3.785. liters. Okay. And how many milliliters will equal a liter? Okay, that's right. 1,000 milliliters will equal a liter. Okay. Okay, so we have to change our quarts and use our density to get the mass. Okay, so I'm going to put that down here. So we're starting off with 6 quarts. We know that there are 4 quarts to a gallon. And then we have for every 1 gallon, we have 3.785 liters. And for every 1 liter, we have 1,000 milliliters. Okay, so then liters are going to cancel out, gallons are going to cancel out, quarts are going to cancel out. And we can use our density to get our mass. Okay, so milliliters are going to cancel out. Okay, so let's do that math. So we get 6 times 3.785 times 1,000 times 0.852, and we're dividing that by 4. So that's going to equal 4,837. And that's grams. Or we can round that up to, since we only have one significant figure, 5,000 grams. Okay, so then we plug it into this equation up here. 5,000 grams. We're multiplying it by this value right here. That's our specific heat. That's our C. So that's 22.47. Oops, sorry about that. Let's see, 47345. And that's joules, grams, Kelvin. And then we have the, oops, I'm just writing all over everything. So then we have our grams are going to cancel each other out. And then we have that change in temperature, which is minus 70 times minus 70. Okay. Times 22.47345 times 70. So our Q, again, it has one significant figure. So we're going to end up with 7. Right, that's 3, 6. Actually, since we have one sig fig, it should be 8 times 10 to the 6. And then that's going to be joules. And it's a negative value. So it's a negative 8. So actually, I'll write it all out first. So it'll be 8 million. I mean, 7,865,707.5. And that's joules. We can put in scientific notation as, and then also sig figs. There's only one sig fig that we have. So then that would be 8 times 10 to the 6 joules. And that'll be our answer. Okay. Questions? Okay. So it's approaching 7 o'clock. I'm going to let you guys go. There's only a couple more problems, but a lot of the problems are kind of like, well, they're not as work heavy as this one. They're less work heavy, but if you remember, you have two equations. You have Q equals MCAT, and you also have Q equals mass times delta H, or moles times delta H. Okay, so those are the two equations that you're going to be using for energy. Any questions? Okay, we'll study. Good luck. And I'll see you guys for lecture tomorrow. You guys have a good night.